Today, I'm going to prove to you that the Earth is flat. In order to do so, let's start with this simple equality. A squared minus a squared equals a squared minus a squared. No doubt about that. Now, on my left-hand side, I'm going to factor an a out of a squared minus a squared, so I'll just get a multiplied by a minus a, and this just simply equals, well, I'll fully factor this side, so I'll get a plus a times a minus a. Now, next, I know both sides share a factor, but allow me to simplify this a little bit first in order to show you. So a times a minus a is equal to 2 times a times a minus a. Now that factor I was talking about is a times a minus a. So I'll divide both sides here by a times a minus a. After doing the division, I find that 1 equals 2. I want this to be all the way simplified, so I'll also subtract 1 from both sides. And here I just found 0 equals 1. So how will that help me prove that the Earth is flat? Well, let's do a quick, just a rough definition of curvature. So I understand the Earth is round, and basically curvature tells you how different something is from a line. So if the curvature is 0, it's a straight line. If it's anything else, it's not a line. And we know the Earth is in fact round. So a couple true statements I could write would be C, the curvature of the Earth, is equal to itself. Then I could also write the curvature of the Earth multiplied by a squared minus a squared is in fact equal to the curvature of the Earth multiplied by a squared minus a squared. Oh, let's go back and look at our work now. If I were to multiply everything here by c, I'd get c times a squared minus a squared is equal to c times a squared minus a squared, and I'd have to multiply every step by our factor of c, which is the curvature of the Earth. So I got down here, then I get 1 times c is equal to 2 times c. Have to subtract 1c away from both sides. Then I get 1 times c equals 0, or simply c equals 0. Well, I know if the curvature is 0, then I must be looking at a line. So what I just showed you here was actually an inaccurate representation of the Earth. In fact, the curvature of the Earth here is just this line. So let me just draw a line. And we know this line is in fact the curvature of the Earth. Therefore, the Earth is flat. Now, we obviously know the Earth isn't flat, and it's your task to tell me what I did here that was just a very basic algebra error that allowed me to make this insane conclusion that the Earth is flat.